In previous video, we have seen how we are going to use the inverted index data structure for storing the terms and the documents. Now, how it will utilize the memory efficiently, that we are going to see in this video by applying the compression techniques. But what do you mean by compression in inverted index? Now, in previous video, we have seen that we are having three terms and these are the document IDs in which those terms are existing. So, I have prepared my inverted index. Now, what collection statistics is telling me how big dictionary and posting you are using and how much memory you need and what are the types of the compression, that is the dictionary compression and posting compression. So, these all contents we are going to see in video one by one. Okay. So, why you need compression? Because you want to use your disk space in a efficient way. Because if my disk space is increasing, if I want more storage, then that much amount I have to spend. So that cost I want to reduce. I want my information retrieval to be a cost effective process. Okay. Now, if existing data is utilizing the less memory, then the remaining memory I can use to store more data, to store more documents. Okay. And as more number of the documents are stored, it will increase the speed of my search process. Now, even it will increase the speed of transferring the data from the secondary memory to the primary memory, that is from the hard disk to the memory. Okay. So, what are the steps here? Read your compressed data, then decompress it. So, this process is more faster than reading an uncompressed data. Okay. And the decompression algorithms are running in a faster way. So, that is why you should go for the compression. Now, what are the types of compression those are available? As I told you, dictionary compression and posting compression. Now, what you are doing in dictionary compression, you want a dictionary compression to be small enough so that it will be stored in your main memory. Okay. I hope everyone understand what is the main memory and what is the secondary memory. Now, the main memory is directly accessible by your processor. Okay. So, if your data is easily available in main memory, then it will reduce the time, it will increase the speed of retrieval. Otherwise, what I have to do, I have to move everything from the secondary memory to the main memory, and which will waste my time during this movement only. So, if your dictionary is small enough, then you can put it in main memory only, and from where you can access it directly. In the same way, if your dictionary is small, the posting list is also small. Okay, and the posting list will be part of your main memory again. Means both will be stored at same time. All your inverted index will be in main memory only if it is having the less size. Now the posting files, it should reduce the disk space that you need to store the posting. It will decrease the time required to read the posting list, as well as most of the search engines will keep the posting in the memory only. Okay, and if it is compressed, then only I can store it in the main memory. Okay. Now, just have an analysis. Okay, this is one of the compression algorithm, that is what Reuters RCV1, and what it is telling us, what are the document statistics. Suppose you are having documents 8 lakh. Okay, then the number of tokens per document are 200, that is just an average. Then the terms are what? Nearly 4 lakh. Then if you are including any space or the punctuation like special symbol, then how many bytes I need to represent one token? 6 bytes. The case when I am removing all these spaces or the punctuation symbols, then in that case, how many bytes per token I need? 4.5. So, this reduction you should observe. Okay. When per token you are reducing 1.5 byte, then definitely it will affect the total storage requirement. Okay. So, the average bytes per term are what? 7.5, and non-positional postings will be what, nearly 100 lakhs. Okay, nearly it is more than 1 crore, I think, 10 crores, I think. So, what is the observation? Pre-processing greatly affect the size of the dictionary and the number of the posting. Exactly. As you have seen in the previous example, when I am removing the spaces and counter, then the memory requirement for each of the token has been reduced by 1.5 byte. So, that is what known as a pre-processing step. That is what your stemming is doing. As we have seen in the previous video, u.s.a is equivalent to USA. Okay, so no need of those dots. So that is what we are doing in the stemming. Then the case folding means what? Yes, uppercase, lowercase. Go to one case conversion. Okay, convert your all data to the uppercase so that all my documents will be in the uppercase only. I will neglect the lowercase or convert everything to the lowercase. Then the stop word removal. There is no use of stop words in your retrieval process, so remove it. Then the next one is what? Percentage reduction can be different based on the properties of the collection. Yeah. Percentage reduction means what? The memory requirement reduction whole and so on depends on your documents. What type of the terms are present in your document. Okay. Now, what do you mean by lossless and lossy compression? As the name is suggesting, in the thought of reducing the memory requirement, I should not lose the important data. That is what the lossless. When I am losing the important data, then that becomes a lossy. Means, listen, every information is preserved, then it is lossless compression. Discarding some of the information, then it becomes a lossy compression. Okay. Now, vocabulary versus collection size. How big is the term vocabulary? Okay, that is how many distinct words are there. For each distinct word, I need one row. So, that differentiation matters. Okay, can we have one upper bound? Means, is there any threshold for the number of the distinct words in your vocabulary? Okay, and of course, vocabulary will keep on growing so that your collection size is going on increasing. Now, there are two laws. One law is what? Hebb's law. What it is saying? M is equal to K into T raised to B. Now, here, what is M? That is the size of your vocabulary. Means the number of the distinct words. Then the T is what? Number of tokens in the collection. Now, here, K I should assume in the range of 30 to 100. That is a constant. And B is what? 0.5. Now, what this law is telling me? That when you are trying to take the log or the log plot of your vocabulary size, so it is what? M versus T. M means what? Your vocabulary. T means what? The number of the distinct terms. Then Hebb's law predicts a line with the slope about half. Okay. And it is the simplest possible relationship between the two in log space. And this is called as even empirical law. Now, what is the Hebb's law is saying? Hebb's law is telling me the vocabulary size in my collection. Now, here in the Hebb's law, we want to relate the frequency of the terms. Means in Hebb's law, you might have seen how many distinct words are present. Means what is the count of your words? What is the count of your term? What is the count of your token? But here, what is the frequency of that term will be considered in Hebb's law. So, what the Hebb's law is doing? In natural language, there are a few very frequent terms and very many very rare terms. Yeah. Means for example, listen, a particular term, aesopia, that is very rare. It is most frequent. So, that word frequency does matter. Okay. So, Hebb's law is saying what? Ith most frequent term has a frequency proportion to 1 by I. Means your CF, that is a collection frequency. Means the particular ith term is existing how many times in my collection is inversely proportional to 1 by I. So, instead of taking 1, here I am taking k. Okay. So, the k is a normalizing constant. Now, the number of occurrence in the term t is given by the CFI. Okay. So, you should remember this law. What the Zipf's law is telling? It is considering the term frequency, and here the collection frequency is represented by the CFI, and it is inversely proportional to 1 by I. I is your term, which is equivalent to k. Okay. K is just a constant, a threshold value. Now, compression. Yeah. So, considering both vocabulary and the term frequency, we got two laws. So, these two laws we are going to use in the compression. Here in compression, what we are doing? We are reducing the size, we are compressing the space. For what? Both, for dictionary as well as for posting. So, it may be a Boolean index or it may be a positional index. So, we will consider the compression schemes, dictionary compression and posting list compression. Okay. So, these two types of the compression we are going to see in upcoming videos. Thank you.